Why do particles seem to follow their paths as if an invisible force is pulling them? It might look like they are being dragged along, but in energy filament theory, we prefer a much simpler explanation. Particles aren't just being pulled. They are actively finding their path as they move. Imagine that the entire universe is surrounded by an energy sea, and within this sea is a pre-laid map made up of gradients and textures. The tension field shows where things are tight and where they are loose, and it tells you where the terrain slopes downward. The texture field, on the other hand, helps the particles find the smoothest, most stable paths, so they don't slip or lose their way. Now, let's put this into the context of how fields operate. Think of the energy sea as a kind of invisible landscape with its own rules for how particles interact. The local speed of light can be seen as the fastest rate at which energy within this field can respond to an action or push. In areas where the energy sea is tighter, it can respond faster, quickly passing energy or movement along the next point. But in areas where the energy sea is looser and more elastic, energy takes longer to travel. This sets up the foundation for how particles interact with the fields around them and helps explain how they move in such a predictable manner. Instead of imagining that particles are simply dragged along by some unknown force, we should think of them as navigating through a landscape that has been set up by the energy sea. This landscape is made up of paths that particles can choose from, with each path having a certain level of difficulty or energy cost. Some paths are much easier to follow because they require less energy and cause less disturbance. The paths particles choose are the ones that minimize their effort and energy, making them the most efficient way forward. This process isn't random. It's controlled by each particle's own unique near-field texture. You can think of this texture as being like the tread on a car tire. Just as certain tires are better suited for specific terrains, particles have textures that make them more suited for different paths in the field. For example, electrons prefer paths that follow electromagnetic textures because they align with their own characteristics. Neutrinos, on the other hand, prefer paths defined by tension fields, which allows them to glide through different materials with minimal interaction. Protons have even more complex behaviors because they have to navigate both the strong nuclear forces in their core and the external tension gradients in the field. Instead of thinking of a force dragging a particle, it's better to picture the field laying out multiple potential paths, and the particles choosing the one that minimizes energy and effort. The particle's path is determined by its own texture and the landscape of the field. The trajectory you see is the path the particles selected, based on trial and error. The particles don't just follow a straight line because something is pulling them instead. They are continuously choosing the easiest route available, given the current conditions of the field. This entire process is an elegant dance of energy and terrain, with the particles making constant adjustments to find the most stable and energy-efficient path. What we interpret as a predictable path is actually the result of the particles interacting with the landscape of the field, selecting the most efficient way forward. In the upcoming season, we will go deeper into how this interaction of finding a path translates into observable forces and how these forces shape the behaviors we see. For now, just keep in mind this fundamental takeaway: particles aren't being dragged through the field by some invisible hand. Instead, they are selecting the most efficient paths from the many options laid out before them. Tap follow, share it on New Physics, Clear Universe.